Hi friends, good morning. Welcome to my channel, Belagali's class. My friends, we have completed with applications of trigonometry. Almost that chapter where you have one example under 3 mark. That chapter almost by taking 5 videos or 5 classes we have done in detail. The basics I have done. Then I have considered examples from the exercise 12.1. Almost major all examples I have done. Even considering 1 or 2 examples from the solved I have done. The remaining 2-3 examples under solved you can do them. They are good examples. Even after that I have done some objective type questions which are important for CET as well as any competitive examinations, my friends. Any competitive examples related with mathematics. It is done, my friends. Done. Okay. Next, today I want to start with a new chapter. Which is, my friends, statistics. This chapter is statistics. It is statistics, my friends. Another important chapter. Even in this chapter also, you get one long type questions. Maybe in example under 4 mark questions. The examples are quite simple, my friends. Simple. Especially this year, they give another simplest example. I hope. Yes, my friends. Now, from today we will start with statistics. This statistics is not new for you. Already you have studied this statistics in 9th standard. When the statistics is studied in 9th standard, almost all basics, my friends, basics in statistics, I hope you might have studied in 9th standard. Even then, to the point what we needed for this year, for 10th standard, just I will taking one class, I will explain those basics, my friends. If I give those basics, it is first good for me. Why? Everything is explained. Next, it is better for you also. Therefore, my friends, first today, considering the basics that you have studied in 9th standard, I will explain it. Later, I will start with what? This year, 10th standard statistics, my friends. Again, on this chapter, you have what? One example under 4 mark questions. We will see, ma'am. I will discuss that question paper. Yes, my friends. The word statistics is derived from the Latin word. It is a Latin word, my friends. Latin word status. Status is a Latin word meaning a state. Statistics deals with the collection, organization, analysis, interpretation, and presentation of what? Numerical data. Yes, my friend. The word statistics is derived from the Latin word status. It deals with, the subject deals with the collection of data, organization of data, analysis of data, interpretation and presentation of what? This numerical data. After collection of data, presenting or present them in a form which is meaningful. That presentation must be meaningful, my friends. Presentation of a data, what we collect, what we collect should be meaningful, easily understandable, and gives the main features at a glance. See, first, after the collection, it is what? Statistics deals with collection, organization, analysis, interpretation and presentation of this numerical data. After collection of this data, then you have to represent them in a form which must be meaningful, easily understandable, and it must give the main features at a glance. Actual information collected, first step, my friends, collection. First step, collection means what? It is a collection of data. First it is. Then organization, everything. Information collected, that first information, actual information collected is called as raw data. It is called as raw data. Now, for example, consider the marks obtained in maths test by 10 students. Consider the marks obtained by 10 students in maths test as follows. Yes, my friends. These are the marks scored by the 10 students. 55, 36, 95, 73, 60, 42, 78, 75, 25 and 62. Is it any number? 3, 6 plus 4, 10. Yes. These numbers, numerical numbers, my friends, these are the scores, students score in maths test, in maths subject. If they give this form or collection of data in this form is nothing but raw data. If this raw data is arranged either in a ascending or descending order, like first very lowest value scored is 25, then the lowest is 36, then the lowest is 42. In between those numbers comes math. What about the highest is 95, second highest is 78, 75, 73, 60, like that comes, my friends, everything dash here. Like this it is in the increasing order, in which 25 is the lowest marks scored. 25 is the lowest marks scored, and 95 is the highest marks scored. If you arrange either in a ascending or descending, you come to know the lowest and the highest marks scored by the students. The difference between highest and lowest values, in the data, that difference is known as range of the data. All these words comes, my friends, while doing the examples. Even one more question they may ask, what is the range of the data? What is the range? Range is the difference between highest and lowest value in the given data. What is the highest here? 95. What is the lowest? 25. Then what is the difference? 70. Therefore, here the range of this data is 70. The range of the data is 70. It is good, my friends, if it is 10. If they give the number big, like what? In a big colleges, the number of students are more, like what? 100, 200. In such cases, it goes very difficult to arrange them in the form of what? Ascending or descending. For that, I will consider one simple which is I can accommodate on the board. If the given data is large, it becomes difficult to interpret, to arrange what? Ascending or descending order, and it is quite time consuming. In such cases, ma'am, we go with a different trick. I told here, whatever we, after the collection, we represent the data in the form that should be meaningful and understandable. So, I will explain this also, quite consuming this also, by taking what? Consider the marks obtained by 30 students as follows. Yes, my friends. I write what? The marks scored by these 30 students, yes, my friends, see, yes, my friends, those scores of those 30 students is as follows. These are the scores of the 30 students: 10, 20, 36, 92, 95, 40, 50, 56, 60, 70. In a row there are 10 students. How many rows are there? 3 rows. Means it is scored by 30 students in maths test only out of 100 marks. It is out of 100 marks scored in maths test by the students. 100 marks. Out of 100 marks. Out of 100. Yes, my friends. Second row, 90 to 80, 80, 70, 72, 70, 36, 40, 36, 40, 90 to 40, 50, 50, 56, 60, 70, 60, 60, 88. These are the scores or marks scored by 30 students. In this case, my friends, again what? Again what? Writing in the form of what? Ascending or descending order is tedious, time consuming. It is with the 30 students. If the number of students is 100, in that case it goes still what? Time consuming, and we feel what it is a boring. In such cases, what we do is, we will collect this, can be analyzed as 4 students scored 70 marks. There is 70, my friends, 70. This is 1. This is 2. This is 3. This is 3. And it is 4. 4 students have scored what? 70 marks. 36. 1, 2, 3. 3 have scored what? 36 marks. Only 1 student scored what? 10 marks. Like that, my friends, you are going to write all these, my friends. How many? The different marks are there. Like that, you are writing this. In this case, the numbers, my friends, the numbers 4, 3, 1. These numbers are called as frequency of marks. It's a new word, my friends. Note it. This, what is this 4? It is a number of students who scored 70 is 4. Number of students scored 70 is 4. 3. Number of students scored 36 is 3. Number of students who scored 10 is 1. Like that. There are many you can write like this, my friends. In this case, these numbers, my friends, 4, 3, 1 are called as frequency of marks 70, 36 and 1. Therefore, frequency of marks is 70. Therefore, by definition, frequency of marks is 70 is what? Number of students who scored 70. Number of students who scored 70. How many are there? 4. Number of students who scored 36. 3. Who scored 10? 1. Who scored 20? You are going to write like that. 40, 50. You are going to write like this, my friends. My friends. Therefore, this raw data, we write it in the form as follows. This is the marks scored 10, 20, 36, 40 like this. This is frequency. Frequency means number of students who scored 10. What is the number of students who scored 10? Is 1. Number of students who scored what? 20 is 1. Number of students who scored is what? 3. Here we have already written 3. Then what? Number of students who scored 40. 40 here it is 1. Second, third. This is 4th. Yes, 40 is 4. Like that, my friends, the next number, you are going to write it. The last, which is the highest, is 95. How many are there? 95 in this row is 1. Here there is no 95. In the third row also there is no 95. Then number of students who scored 95 is 1. That 1 is the frequency of 95. Next goes 92. The last but one score is 92. This is 1 in the first row. Second, in the second row. Third, in the third row. Then there are 3 students who scored 3. Like this we are going to write, man. This is what? The same raw data we can condense into one table. This is what? The friend who scored 10, 20, 36, 40, we write like this. Instead of writing it this way. Now, this is a little bit condensed. This form of representation of given data, this form is known as ungrouped data. You must know all these things, words, my friends. Only because of this I am explaining. It is. This way is writing is what? It is ungrouped data. Ungrouped data. Again, my friends, this form of ungrouped data can be still condensed. Can be still condensed and represented in the groups. What is the group? Here I have written individual. If you take the groups as what? 10 to 20, directly you are writing 2. If you write 10 to 40, you are writing directly. In the group 10 to 40, how many students are there? 1, 2, 5, 9. 9 students are there. Like that, you are creating the intervals, my friends. You are creating the intervals. Same ungrouped data can be condensed, you see. Can be condensed and represented in the groups of frequency table called grouped data. This is ungrouped data. Next, we are going to give the form of what? Grouped data. Grouped data, which is as follows. We will see, my friends, the same we can write it in what? Grouped data. I will write that grouped data, my friends. C. This form is raw data. This raw data we represented in the second form. Here we have created 2 columns. First column, marks obtained. What is this? Frequency. Frequency means what? Number of students who scored 10. Number of students who scored 20, like that. It is frequency. We have written marks scored and frequency. I told this form of representation is known as ungrouped data or ungrouped frequency distribution. Ungrouped data, otherwise ungrouped frequency distribution. Again, my friends, this ungrouped data, again this can be condensed and represented in the new form. This ungrouped data can be condensed and rearranged in still what? Shorter form. That arrangement is this. That arrangement is called as grouped data. Grouped data, otherwise it is grouped frequency data. Simply grouped data, otherwise grouped frequency data. The same ungrouped data. This is from the raw data to ungrouped. From the ungrouped to, it is, my friend, grouped data. In this case, writing like this, 10, 20 individual marks, we group them. These marks we group them. What is this group? Marks is grouped. It is grouped between what? Number of students who scored between 10 and 19, 20 and 29. Number of students who scored between 30 and 39, 40 and 49, 50 and 59, 60 and 69, 70, 79, 80, 89, 90, 99. My friends, here. In between 10 to 19. 10 to 19 is this, my friends, in between. This 10 to 19 is 19 means what? Less than 20, then there is only 1 student. Between 20 to 29, there is 1 student. Between 30 to 39, there are 3 students. Between 40 to 49, there are 4 students. Like this, we are going to group, my friends. Writing individual marks, we write it the same marks in terms of groups. Then we are mentioning down the frequency, the number of students scored between this interval in this group, 30 to 39. 30 to 39 is what? Number of students are 3. Between 40 to 49, the number of students are 4. Number of students are 4, like this. Between 50 to 59, 5. 60 to 69, 4. 70 to 79, my friends, here. We can count them and we can write. 80 to 89 is 3. 90 to 99, it comes what? 90 means 92, 1. 95, second. Third. This is fourth, my friends. Between 90 to 99 is what? Number of students are 4. 1, 2, 3. One more is this is 1, second, third.
First line to 90 to
95 here, my friends. 95. So the number of students are 4, that we write it in the form of frequency. This, my friends, again we condense it. We condense that ungrouped form and we rearrange them in the form of groups. Instead of writing individual marks, we write it in the form of groups. First, second, down is what? The frequency, my friends. This representation of data is known as grouped data or grouped frequency data. Grouped frequency data. In this case, my friends, these groups 10 to 19, 20 to 29, 30 to 39, like this, my friends, 9 to 99. These groups are called as class intervals. These groups are called as class intervals, or simply, in short, it is classes. Classes in which this 10 is known as lower limit, 19 is known as upper limit. Then the mathematicians introduced one more definition, that is the mid value of the interval. That mid value of the interval. To get the mid value, what you are going to do? Lower limit plus upper limit divided by 2. That is 10 plus 19 divided by 2. Like that, this divided by 2. In that case, we get the mid value. To find the mid value, that mid value is also known as class mark. Class mark. Then what is its definition? That class mark or mid value or midpoint of this classes is the sum of what? Upper and lower limit divided by 2. Sum of these two limits divided by 2. That we get it as what? The class mark or mid value of those intervals. Mid value of those intervals. Yes. That is here. This is groups in which I remove. I hope it is clear now. This is raw, ungrouped, this is ungrouped. Then this is grouped data, my friends. 3 types. One is a raw data, this is ungrouped, and this type of writing, representation of what? Data is known as grouped data. Grouped data. Now, in this, my friends, these are known as intervals or class intervals or simply classes, in which lower limit, upper limit. Next, we go with what? Another few more definitions here, my friends. My friends, I told this is group data in which these are called as what? Class intervals. 10 to 19, 20 to 29, 30 to 39. All these are called as what? Class intervals or classes or simply class. In this class interval, another second column, my friends, comes. In this interval, the number of student is 1. That number of student is called as what? Frequency. Frequency of this interval is 1. Frequency of this interval is 3. Frequency of this interval is 4. This 3, 4, 1, they are nothing but the number of students. I have written here, my friends. Second, the number of students is called as frequency. and that frequency is denoted by F5. F5. Yes, 5. It is a different here. In this interval, this is 1, this is 2, this is 3, this is 4, like that it is different. Instead of writing F, we write it as F5. F1 means what? This first frequency. If I is 2, second frequency 1. If I is 3, the third frequency is 4, like that, my friends. So, it is denoted by Fi, where I stands for what? 1, 2, 3, dash, dash. This is the third result. In the class interval, I have considered only one. 10 to 19, 10, what is the lowest value in the interval? Lowest value in the interval is called as lower limit. The highest value in the interval is known as upper limit. Then this is another definition, my friends, important. The mid value of the class interval. The mid value of the class interval. What is the class interval? Say it is 10 to 19. The mid value of the class interval is called class mark, another definition. This is known as class mark. You must know all these, my friends. That is why I am taking one full class for all these basics. So, the mid value of this class interval, what is that class interval? 10 to 19. That mid value is called as class mark. Then what is that mid value? Therefore, class mark, that is the mid value, is what? Upper limit plus lower limit divided by 2. Upper limit plus lower limit divided by 2. In the class mark, 10 to 19, its mid value is, mid value or class mark 10 to 19 is upper 19 plus 10 divided by 2, which is 19 divided by 2, which is 9.5. So my friends, in the class interval, the class mark is what? 9.5. In the class interval 10 to 19, the class mark is what? 9.5. Similarly, my friends, here 20 plus 29, how much it is? It is 49 divided by 2, which is 49 means what? You are getting 29.5. Here 30.5. It is 49.5. Like this, my friends. You can find the class mark. What is the class mark? You have to add both the numbers, add them, divide by 2, like this. To find what is this, my friend? Class mark. This class mark is denoted by xi, where I stands for 1 to 2. Why xi? Because related with class mark here, class mark of this interval, 9.5. Class mark of this interval is what? Different, it is 19 or 19.5. Like this, it is 29, it is 39, like that. My friends, the values are different. 9.5, 19.5, like this, my friends. Therefore, we are denoting this class mark by the letter xi, where I takes the values 1 to 2. This is about the third result. Third result means in the class interval, you get mid value is class mark. This is the way of finding the class mark. This class mark is denoted by x. This is third one. Now the fourth one is what? The difference between upper and lower limits of the class interval. The difference between upper and lower limits of the class interval is called as class width, my friends. This is known as class width or class size, another name. Class width or class size, and is denoted by h. This h is a fixed number, my friends. It is not like what? Fi or xi. It is fixed number, and h is a fixed number. Therefore, class size is upper minus lower limits. In this first interval, what is it? 19 minus 10, 9. 29 minus 29. 39 minus 39. 49 minus 40 is 9. Therefore, that class size is a fixed number. Class size is a fixed number, which is yes. Yes, my friends. This is known as grouped data. These are known as class intervals. In the class intervals, this is known as what? Upper limit, lower limit. Upper limit plus lower limit divided by 2, that gives the mid value. That mid value of the interval is known as class mark. Class mark denoted by xi. Then the difference between upper and lower limits, the difference is known as class size or class width. It is denoted by h, which is a fixed number. Therefore, class size, upper minus lower limits, which is fixed number. And another is this second column, number of students in this interval, number of students in this interval, number of students in this interval. These are called as what? Frequency. That frequency is denoted by Fi. That frequency is denoted by Fi, my friends. Fi. So Fi, this is xi. These two plays a very important role. What is xi? It is class mark. Add upper and lower limits divided by 2. And it is what? Number of students who scored, it is Fi. And what is this? Another important is class size. Class size means it is a difference. And class mark means it is a sum. Class mark is a sum. Class size is the difference. Remember, my friends, that is frequency. This is about, my friends, about the grouped data. In this again, there comes two types, my friends. In a grouped data, two types. This is one in which the upper limit of the first interval is not same as lower limit of the next interval. Again, see, this is the upper limit of this interval, which is not same as the lower limit of the next interval. See, 39 is upper, 40 lower, which is different, like this. This is called as one type of grouped data. What is another one? You may have 10 to 20. Next is what? Like this. It is 10 to 20. Next is 20 to 30. Next is 30 to 40, like this, my friends. In which you have upper limit of the first interval is same as lower limit of the next interval, second interval. Upper limit of the third interval is same as what? Upper limit of the second is same as lower limit of the next, like this, my friends. This is 30 to 40, this is 40 to 50, like that it comes, my friends. It comes, yes, my friends. Just I will mention one line about this and another line about this. Yes, my friends, explaining this. This is class intervals. In this class intervals, what is the observation? Upper limit of the first class interval is not same as the lower limit of the next class interval. Same. Upper limit of the second class interval is not same as the lower limit of the third class interval. Like that it is. This one. Such a form. I remove it. Yes, my friends. Such a form of grouped data is known as discontinuous or inclusive form of grouped data. This is known as discontinuous or inclusive form of grouped data is the inclusive form of grouped data. For example, is this, my friends, discontinuous form. 10 to 19, 20 to 29, in which, what is your observation? Upper limit of the first class interval is not same as lower limit of the next class interval. In such cases, it is known as inclusive form of grouped data. Second is what? It is equal. It is here, it is not equal. What is the next? It is equal. When it is not equal, inclusive form or disconnected here. No connection between this discontinuous form. And what is another one? These are the class intervals in which upper limit of the first class interval is same as lower limit of the next. Here, upper limit is same as lower limit of the next, like this man. This form of grouped data is known as exclusive form, or continuous form of grouped data is known as exclusive form or continuous form of grouped data. This is one example, my friends, my examples. So, a case where upper limit of one class interval is not same as the lower limit of the immediate next class interval, such is known as inclusive or discontinuous form of grouped data, where you have both equal. Here upper is same as lower, In this case, such grouped data is known as continuous form or exclusive form of grouped data. This, my friends, you must know these differences. That is why I'm explaining. Anyway, I told I'm doing the basics here. Yes, my friends. Next comes in the grouped data. The data clusters around a single central value. Then the value where the data clusters, that value represents the whole set of data, and such a value is called as measure of central tendency. There are three types. I write, my friends, one by one. Yes, see. This is inclusive, exclusive form. Next is that note, my friends. This is another note. I explained about what? Inclusive, exclusive form of grouped data. Now we will come to the main portion of what? 10th standard. Yes. In the grouped data, the data clusters around a single central value. Data clusters around a single central value. This value represents the whole set of data, and such a value is called measure of central tendency. In the grouped data, the data clusters around a single central value. This value represents the whole set of data. That value represents the whole set of data. And such a value is called the measure of central tendency. There are three types of what? Measure of central tendency. The one, arithmetic mean, or simply it is mean. Second, median. Third is mode. My friends, we shall discuss these three one by one in detail. We shall discuss each one by one. First one, arithmetic mean. Arithmetic mean is a definition, my friends. Arithmetic mean is defined as the sum of values of all observations. Divided by the total number of observations, and is denoted by x bar. Again, my friends, there are three main methods to find the arithmetic mean. One is direct method. Second, assumed mean or shortcut method. Third is step deviation method. Yes, my friends. We shall go one by one. The first is arithmetic mean. What is the definition? Arithmetic mean is defined as the sum of all values of all observations divided by total number of observations, and is denoted by what? X bar. There are three methods, my friends. Three methods to find the arithmetic mean. First is a direct method. Second is assumed mean or shortcut method. Third is step deviation method. Again, we shall go for what? One by one, my friends. First, direct method. First is direct. We have started with what? This first one, my friends. First central tendency, that is arithmetic mean. We shall give the definition. These are three methods. In each method, how to find by using direct method. I give the formula and examples. Next, what is the assumed mean or shortcut method? I will explain what is the method. Then I do what? One or two examples on this. Third, step deviation method. This is the third one. Then, what is it? That method I will explain. Then, examples. We shall do one by one. Then, we shall go for what? Example from your exercise. That is 13.1, as it is a chapter number 13, my friends. Chapter number 13. Yes, 1 minute, copy it. Yes, my friends, now I have considered the first method, which is a direct method. I am giving the formula. The formula to find the mean of, my friends, it is important. Ungrouped data. Ungrouped data means as it is given. Is this the formula? Arithmetic mean denoted by x bar, which is the sum of the observations divided by number of observations, where x1, x2, x3, xn are n observations, and capital N denotes what? The total number of observations. The same numerator you can write in brief as what? Using summation sign. Summation xi, I takes the values from 1 to n. I takes the values from 1 to 1 upon this capital N, which is the total number of observations, my friends. This is the formula. Yes, one example, my friends. The heights of 5 runners are 160 centimeter, 137 centimeter, 149 centimeter, 153 centimeter, 161 centimeter respectively. Find the mean height of these runners. That mean height equal to what? Sum of heights of all runners divided by total number of runners, that is x bar, sum of all, 160 plus 137 plus 149 plus 153 plus 161. Just this last number you can verify. 1 plus 3, 4. 4 plus 9, 13. 13 plus 7 is 20. 0, 2, 8, 13, 17, 20, 26. 2, my friends. 2 plus 1, 3, plus 1, 4, plus 1, 5, 6 plus 1 is 7. So, the sum of the numerator is 760 upon 5. There are 5 runners, my friends. There are 5 runners. It is 760 upon 5. Cancellation 1, 5 remains 26. 5 into 5 is 25. 1 remains 10. 5 into 2 is 10. If you simplify this, it is 152. Therefore, mean height of the runners is what? 152 centimeters. Why it is raw? Because the given data is what? As it is given. We have not arranged them in the form of what? Increasing, decreasing, nothing. It is as it is the numerical data. So it is called as what? Ungrouped data. That's why this is the formula. This is the formula to find the arithmetic mean for a ungrouped data. So what is it? Add all the observations in the ungroup divided by total number of observations. These are n observations. This is the total number of observations. The same formula we can write in brief. X bar, xi, I takes the value from 1 to n upon capital N. So this is one simple example. The height of 5 runners are given this. Then you want to find the mean height. Therefore, by definition, mean height is what? Sum of heights of all runners divided by total number of runners. What is numerator? Add all these heights of runners, observations, upon total number of runners are what? 5. Explain. 760 upon 5 is 150, which is mean height of these runners is 152 centimeters, my friends. This today I went through this first class of what? This statistics, my friends. We need lot of basic things. What I mean by raw data, then ungrouped data, then grouped data. In the group data, everything comes, my friends. Class interval, width or mid value, width of the class interval, and everything I've explained, my friends. If you are perfect with these basics, the examples becomes simple. Why? If I refer to the grouped data, immediately you must have in the mind what is the form of grouped data. Ungrouped data, what is it? The form of ungrouped data. Class interval, like that. All those definitions, my friends, you must have in the mind. Yes, my friends. Today this much is enough with what? Then I went with what? There are 3 types of central tendency. Measure of central tendency. Those measure are: first is arithmetic mean or simply mean. Second, median. Third is mode. Now we will go one by one. About the mean, again there are 3 methods. One is direct method, second is shortcut method, third is step deviation method. Again I have started with what? One by one. This is what? Direct method. This is the formula for what? Formula to find the mean of ungrouped data. What is the formula? Add all the observations in the ungrouped divided by total number of observations. This can be written in brief, sigma sign. One small example on this. The heights of 5 runners are this. Then we find the mean height. What is this, my friend? Ungrouped data. Yes, sum of all these heights of a runners divided by total number of runners. These are the heights of all runners added upon number of runners is 5. Add them 760 upon 5, which is 150. So my friends, mean height is 152 centimeter. Yes, my friends. Next comes it is ungrouped data. Next comes direct method for what? Grouped data. This is formula for what? Ungrouped. Next is what? How to find the mean of grouped data. I give the formula and examples, my friends. Okay, we shall do one by one. That I do it in the next class. It is an important subject branch, my friends. Statistics. Earlier, they used to consider this as what? It is a one branch in mathematics. But now it is also what? Grown like anything. You can do, if you wanted, you can do PG in case of only statistics. If you wanted research in statistics to get the PhD, you can do everything in this subject, my friends. Now, especially the your latest technologies like what? Computer science, E and C, all such they are now inclusion of what? Such formulae, statistics, even probability, all these are using in a large scale. That's why these chapters, these basics, these concepts in statistics plays a very, very important in future, my friends. Saying this, today it is enough, my friends. Bye, goodbye, namaste, namaskara, my friends, namaste. Have a good day.